Okay, so this is going to be a quick video just to go over some of the basic things in maths that will help us to do the more complicated things that we are currently doing in Year 5. So this is for parents, for students, in any year group, and it's just going over some basic strategies for the 4 operations in maths. So if we look at addition first, basically we need to know our place value. So if we just take a random addition, we'll make it quite a big one. 363 add 521. Okay, and obviously we want to find out the answer. So there's 2 main ways that we are looking at doing this. The first way is obviously breaking up the number into its values, and we call this partitioning. So we know that we have hundreds, tens and ones here because they are both hundreds numbers. They both have 3 digits. So as we look at this number, we can start to break it down. So we know that in this number we have 300, and in this number we have 500. And I'm going to put those together, and I'm going to just add those together first in a moment. Then we're going to do 60 and 20. Now we know it's a 60 because it's in the tens column, and we know it's 20 because it's there. So we're going to do 60 and 20. And then in the last column, obviously, we have our ones, and they're just single units, so we have 3 and a 1. So let's just put that there. And as you can see, now the reason why I'm writing it in such a funny way is because I want to keep the columns lined up, so I can understand that I've got 520 and 1, 521. I've got 360 and 3, 363. Now I could do it this way. So I know that 3 and 5 is 8. So I know that 300 and 500 is 800. I know that 6 and 2 is 8. So I know that 60 and 20 is 80. Now as I write my answer, I'm keeping my ones in the same column. And then I know that 3 and 1 is 4. So all I'm going to do, I'm going to add these together, and I should get 884. I always add from the smallest value. So you always start with the ones, and you work this way, going left, okay? So we've got 884. This way is a really nice way to do it in your head, because you can remember how to partition, and you can do it quite quickly. So you know 300 and 500, 60 and 20, and 3 and 1. And the more you do it, the more you do it, the faster you will become. So if it's a bigger number, let's just use the same numbers now, and we are going to now think about using a written method. So this comes in useful when you have like thousands or 10,000s. What we're going to do is we're going to lay it out like this. We're going to do our 363, and we're going to make sure that we have them in the correct columns like this. So we know that when we write our next number, we're going to do this underneath. We're going to do 500 because it's in the hundreds, 21. And then we can add them together like this. Now this is the way that most of our children do this, and it's really quick, really easy, and you only need to add single digits, which makes it really quick. So again, 3 and 1 is 4, 6 and 2 is 8, and 3 and 5 is 8. And you get the same answer, 884. So that's addition. Again, you can have a little practice at home just by doing it that way. And again, you might think you already know this, and most people do, but the more you practice, the more confident you get, and you become faster and faster. Let's do one more quick practice. Let's take a really big number. Let's do 25,207, and let's add that to 5,972. So it's a much bigger question now, but we can use the same idea to do this. So we're going to take the number, and let's do the column method first. So we're going to do 25207, and then we're going to take this number. Now we notice it's only 4 digits, so that means it's only a thousands number, so we need to start it in the right column. Okay, lots of people start it here and it's wrong. It needs to be lined up. So you've got your ones, your tens, your hundreds, your thousands, and your 10,000s. And we're going to add these together. So let's have a little look at what we get. So we get a 7 and a 2, which is 9. We get a 0 and a 7, 7. Easy so far, single digits. Now, we get a 2 and a 9. We know that 9 and 2, 2 and 9, is 11. So we haven't got space to put 11 here because it's only one number allowed. So if you think about 11, if we put 11 over here, 11 is made up of 1s and 10s. You have 1 and you have 10. Okay, so what we actually have to do is we need to take one number here, so we're going to put our ones number here, and we're going to put the next number in the next column. I'm just going to pop it up the top, so I'm ready to use that. Okay, so I've taken my 11 and I've put the ones number here and the tens number up here, so it's ready. Now I've got 5 and 5, which is 10, and I add the extra 1, which is 11, and we do the same thing again. We put the 1 there and we carry up the 1. We're moving it over to the next column. Then we've got 2 and 1. Of course, that's 3, and that's where our number ends. Now, with the big numbers, I like to put a little comma going this way every 3 numbers, because it helps you read it. So if we take this number, for example, we've got 31 here, and we've got 179 here. So reading that, that's obviously going to be 31,000. And then this is going to be 179. So when we say it, 31,000, there's our little break. We've used a comma. 179, and that helps us with reading. And if you've got a really big number, I know we're going into some place value here. Let's just take a really big number. Let's take a millions number. There we go. What we've got here, if we go from the edge, from the smallest number, and we go 3, 1, 2, 3, comma, 1, 2, 3, comma. This will help us now read it. 3,521,175. So you're breaking it down into little chunks, and the commas really help you to read that number much quicker, because you already know when you're going to stop and finish each value, so to speak. So you've got your millions, your thousands, and your hundreds. Okay, moving on, we're going to go to subtraction now. So subtraction is the inverse of addition, so that means we can use addition to do subtraction if we want to. So let's look at a few examples. Let's take a big number, 357, and let's take away a big number. Let's take away 45. Now, if we were to do this in our heads, we would partition again. We'd think about the 7 and we'd think about the 5. Okay? 7 take away 5 is 2. So you know that that last number is going to be 2. We always start with the smallest value. Then we look at the next two. We've got a 50 and a 40. Well, 50 take away 40 is 10. So we're going to have a 10 in the tens column. And obviously the hundreds column is left. We've got 300 here and we've got no hundreds here. So it's just going to remain as a 3. So that's the way I would do it in my head, using partitioning and working at each place value first, okay? Now, it doesn't matter how fast you do it. You can do it really slowly, but it's about making sure that you are accurate with your subtraction. If you're not feeling confident and you can't do it in your head, then you could probably do it using a written method, using the column method. So let's line this up like we did with our addition, but let's make sure that the biggest number is on the top. The first number is the biggest number, obviously, and we're going to line it up the same way. So we've got 7, take away 5, that's 2. 5, take away 4, we're still going down in columns, is 1. 3, take away, now here there's nothing, so we're taking away nothing, so it's going to stay as 3. So there's our final answer, 312. Now, the good thing about subtraction is that you can do it a number of different ways, and this is where people get confused. If you have, let's do 295, and we want to take away 287. Now, you could do it this way. You could do your column method way. Let's do it. Let's just get the answer. 5 take away 7. No, we can't do that. Even though the bigger number is on top, this 1's number is smaller than this number. Okay, so we have to do something. We're gonna go. I always say we go next to the number next door and we steal a number. This is called borrowing, but I like to call it stealing because you don't actually give it back. So that's going to be an 8 now because I've ripped one away, and I'm going to put it over here next to this number. So this becomes a 15. Okay. Now, if you think about this using hundreds, tens, and ones, you've just taken a 10 and you've given it to this one to make it 15 instead of 5. So now we've got 15 take away 7. Okay. Which is 8. Then you've got 8 now, not 9. We've got 8 take away 8, which is 0. That's fine, we can do that. And 2 take away 2, 0. So the answer, no hundreds, no tens, just 8. So you could actually write this answer as just 8. You don't need to put the zeros there. Now, the reason why I think this is not a good idea, because this question here, you've got two numbers that are very close to each other. You can see that the difference is only 8. So as a mental method, I would actually use adding to do this. So if someone said to me, what's 295 take away 287? I would use the inverse. And I would say, well, how many do I need to get from this number back to this number? Because that's essentially what you're finding. You're finding the difference. So 287, and then in my head, well, I know my number bonds. I know that that's going to be 8. If you're not sure, you can practice by counting up. So we've got 287, 288, 289, 290, 291, 92, 93, 94, 95. And you get 8. And there's your answer by counting up, okay, using the inverse. That only is a good idea if you have numbers that are close together. If you have like a really big number and a really small number, let's do one more example. Let's do like 5,109, and you want to take away, I don't know, 340. Now counting up is going to be a bit trickier because you have to count up further. So I would just use the column method here. It's a nice efficient way. 9 take away nothing is 9. 0 take away 4. This number's too small. So let's go here and let's steal. That's now going to have nothing. This is now going to be 10. 10 take away 4, 6. 0 take away 3, can't do it. It's too small. So we're going to go next door and we're going to steal that. That's now going to turn into a 4. Remember, we're only taking 1 away. So 5 turns into 4. Where's the 1 gone? It's gone here to join the 0 to become a 10. 10 take away 3 is 7. 4 take away nothing is 4. Okay. So some methods there. I would stick with the method that you find most comfortable and practice that method so you have it kind of built into you. You don't need to think about it, okay? So that's that one. Let's go on to multiplication now. With multiplication, lots of things can go wrong if you're not careful. Well, first things first, let's get a multiplication. We're gonna make a big one. Now, it's worth saying that with multiplication, you need to know your times tables. There's no easy way to do this. You just need to know your times tables. You need, if it's times 7, you need to know your 7 times tables. If it's times 9 or multiply by 9, you have to know it. The easiest way to learn it and to practice it is to just repeat over and over again. Get yourself a multiplication square, which I'll give you, if you want one, I'll give you as many as you want. And you just fill it in and you just say it and you say it and you say it. There's no other way to do it. So if we were looking at this using, if you remember with addition, we use partitioning. So we know here we've got a 300. Let's just write this down here. We know we've got a 50. And we know we've got a 2. You could take each of these values from this number and you could times by 7. So we could do 300 times 7. You could do 50 times 7. And you could do 2 times 7. Let's try that first, and then let's see what we get. So we get 300 times 7. Well, if you know your 7 times table, or your 3 times table, you know that 3 times 7 is 21. So now you've got 21, but it's not 3, it's 300. So it's going to be 100 times bigger. That's easy. Just 2 zeros here, 2 zeros there. 2,100. 50 times 7, again, if you know your 5 times table or your 7 times table, you know that 5 times 7 is 35. It's not 5, it's 50. 1 0 here. You add the extra 0 there because you're not timesing by 5, you're timesing by 50. And the last one, nice and easy, 2 times 7 is 14. Now you'll see, as I've written my answers, I've lined them up so that I can now just add these together using my addition skills, and I can get the final answer. I've got a 4, I've got a 6, I've got a 4, and I've got a 2. Okay, so I've got 2,464. Now, if you don't like doing it that way, there's a few other methods we can do, and we've been practicing these in school, and again, it's whatever method you think works best for you. So I'm going to show you the easiest one, the one that most of us do, and that's taking the number, multiplying by 7, and you lay it out much like previously with the column method in subtraction or addition. You line up your digits and you do it step by step. So you've got here 2 times 7. Well, we know that's 14. Again, I can bring that up there because I haven't got space for it there. We've got 5 times 7, 35, but we've got an extra 1 here now that we need to use. So 35, add the extra 1, that makes 36. Again, there's no room for the 3 now, so I'm going to put it up here for 36. 36. Now we've got the last one, 3 times 7, which we know is 21, but we've got an extra 3 to use here. So that's 21, 22, 23, 24. And we get the same answer, just a different way. Okay, and then the final method, there's hundreds of methods you could use. Some of them are a lot more elaborate than others, but this is a really nice one, and this really gets the children to think about place value a lot more. So I'm going to split up the number. I'm just going to use a little grid like this, really easy, and I'm going to split up the number. So we're multiplying, and along the top I'm going to put my big number, so 352. So again, if I think back to this, I've got 300, I've got 50, and I've got 2, and then obviously I've got a 7. My 7 is just going to go down the side, and I'm going to fill in each box. Now, because I've done this before, this should be easy, but again, if you know your times tables, let me zoom in. If you know your times tables, it's easy. 7 times 3 is 21, 7 times 300, 2100, or 2100. 7 times 5, 35, but it's not 35, it's 350 because we were timesing by 50. And then 7 times 2 is 14. You've got the same answers as here, add them together, and you get the same answer, okay? So I personally like this one because this one is much quicker. However, it is important to still remember that this number here, for instance, this is not a 3, this is a 300. This is a 50 and this is a 2. You have to remember your place value. So as a little practice, I would try a few different methods at home, see which one you are more comfortable with, and whichever one you like the best is the one that you should do. The last one for today is division. Division is probably the hardest of the 4 operations because you need to know your multiplication. So you don't just need to multiply now, you also need to use multiplication to do something else. Now, it's important to know that division means sharing. That's basically what it means. So we are going to share whatever we have. So the basic concept that every kind of student goes away with is, let's imagine that you have 3 people. There we go, lovely 3 people there. And you want to give them some sweets, okay? And you have, I don't know, let's say we have, how many sweets is this? I'm not even going to count. I'm just going to do loads of sweets here. There we go. So you have to share them. And this is what dividing is. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. I know that to share these between 3 people, they're each going to get something. So the question would be 15 divided by 3. Now, if you know your 3 times table, you've already got the answer, okay? Because you know that if let's do our 3 times table. We've got 3, 6, 9, 12, 15. There's our number. 5 times 3 is 15. So 15 divided by 3 is 5. And we can check this with our picture by thinking, right, okay, let's group them into 5. So we've got 5 there. Let's do another group. 5 there. And we've got 5 there. So it's lovely to have a little picture just to check. So you know that this 5 is going to go there, and these 5 are going to go there, and these 5 are going to go there, and these 5 are going to go there, and so on. So it works. You need to know your 3 times table. That's the most important thing here. Your divisor, which is the number you divide by, is the important number that you need to have some knowledge about the times table. So let's take a harder one then. Let's take a bigger question. 275 divided by 9. Now, we've got a problem with this. We can't draw a picture because the number is too big and it would take us too long. So this is how we are going to approach this one. We need to know our 9 times table. So before I even start to do anything, I'm going to write down my 9 times table so that I can use it to help me. Now, if you've got a 9 times table in your book, just get it out, use it, and there we are. I'm just going to go up to 10. So I've just written it down the side there so I can use it in a moment. So let's have a look at this question. 275 divided by 9. So we've got 275 sweets, and we want to share them between 9 people. Okay, it's all about sharing. So how do we do it? This is what I'm going to do. I'm going to take my dividend. This is the number that we want to share. We want to break it up, and I'm going to put it inside this lovely little box here. And I'm going to make sure I have some space because in a moment we're going to be using this number, and we're going to have to work out what we're so make sure you've got some space between the number because you want things to be nice and clear and neat. And we're going to put our dividend, our dividend is in the box. We're going to put our divisor, which is the number that we're splitting it into, on the outside. And we're going to start asking ourselves this question. How many 9s can I fit into 2? Well, if we look at our 9 times table, 0 times 9 is 0. 1 times 9 is 9. Well, 1 is too much because we've only got 2 here. So the answer is a 0 here. It doesn't fit. We know that multiplication is the inverse of division. So 9 times 0 is actually 0. Now, if we just think, I'm just going to split this up like this so we can see what's happening here. This 0 and this 2, we're going to take them away. And we're going to see how, well, we still got the 2, okay? So we've still got a 2. We're not finished. Let's drop down the 7, okay? There's an old mnemonic that people remember, and it's basically, does McDonald's sell cheeseburgers, I think, or burgers? Yeah, does McDonald's sell burgers? And basically that stands for divide, multiply, subtract, and then bring down. And I'll talk about this now in a minute. So what we did in the first question, the first part of the question, is we did how many times does 9 fit into 2? It doesn't. 0. 9 times 0, we multiply now, is 0. Put the 0 underneath. And then we subtract. We get 2 here. And then we bring down the next number. So now we've got 27. So what do we do now? Let's have a look. How many times does 9 go into 27? Well, this is nice because if you look at the times table, actually 9 times 3 is 27. It's perfect. So the answer is going to be 3. 9 times 3, let's check it with multiplication. 9 times 3 is 27. That means we have nothing left over, because 7 take away 7 is nothing, 2 take away 2 is nothing. So we have nothing left over. So what do? We bring down our next number all the way down to what we just got, 5. Nothing here, 5. Does 9 go into 5? It doesn't. Okay? So what do we do now? We've reached the end. We've got nothing. Now, there's 2 options. The option I'm going to do right now is I could just say I've got 5 left over here. And I could say remainder 5. Okay? And you can check this. So remainder means extra. So if we had these 3 children here and we've got the 15, imagine the question was 16 divided by 3. Well, the answer's still 5, because they all get 5, but there's just 1 left over that we can't do anything with. So that's what we've got here. We've got something that we can't do anything with. Okay, let's just check it using some multiplication. So if we use the inverse, 30 times 9 should be 275, but with 5 missing. Let's just check it. 30 times 9. So 0 times 9 is 0. 3 times 9, 27. Aha! It's 270. But if we add the extra 5, well, there it is, that we missed, let's just add it on there, and we get 275. So that's the first thing you can do with division. Now, there's another thing you can do with decimals. So instead of having a remainder, you could actually create a decimal number. We're not going to do that today because we don't need to worry about that at the moment. We just need to know that we've got a whole number here and we've got some left over. So each child will get 30 sweets out of the 275, but there will be 5 left over that we can save, because it wouldn't be fair if you give those 5 extra sweets to somebody else. It needs to be fair. So going back to this sharing, it needs to be what we call equal. It needs to be fair, and it needs to be equal. That's why we have our remainders and we keep them separate. Otherwise it wouldn't be fair. Okay, have a little practice of those 4 operations, and I will put up a new video very soon about how we can use these skills and these strategies to help us complete our fractions work in class. So yeah, thank you for watching. I hope this has helped you, and goodbye everyone. Cheers.